Good morning, everyone. Thanks for joining us today in our webinar for situational awareness. We have Brian Martin, our senior system consultant, presenting the concepts of situational awareness today. Brian, I'll leave it to you to present.
All right, thanks, Edward. We'll go ahead and get started here in just a minute. So I can hear people are still joining. Edward, can you confirm that you hear me okay?
Brian, I can confirm.
Yeah, it's okay for me.
Yeah, I can hear.
Okay, great. All right, well, we'll go ahead and get started. This session that I have, I've kind of titled it Situational Awareness Demystified, and I kind of wanted to explain a little bit about situational awareness and where we as a Wonderware brand are and what we see as a lot of the value that's available in situational awareness, as well as the value in what we've supplied for the situational awareness content that you as our customers have the ability to leverage and take advantage of all the things that we've provided. So that'll be my goal over about the next 50 minutes or so. So it should be just about under an hour, and we should be finished hopefully right before lunch. So my name is Brian Martin. I am, as Edward had mentioned, a technical system consultant or technical sales consultant with Schneider Electric, pretty much 100% focused on the Wonderware brand. As you can see, my email is there. If you have any reason to contact me, my email is brian.martin@wonderware.com. If you want to go ahead and send me any kind of feedback or any questions that you might have, I'd be happy to entertain any of that. So I think, the first thing is why situational awareness. And now I've been with Wonderware historically for quite a while, just over a couple of decades really, working with Wonderware software and beginning mainly the InTouch software since it was the flagship product from Wonderware. So, why over the last, half a decade or so, 5 years or so, if we've started to look at the situational awareness? And when we look at why, if you look at the reason for being aware of a situation, the really important part of that is if something abnormal happens. So, a disturbance or a series of disturbances in a process that cause something in the plant or the plant operations to go awry, to deviate from what, its normal operating state might be. So, using some of the statistics out there, this one happens to be an ASM consortium for the abnormal situation causes, and I'm not sure how well it shows through on the WebEx because those colors are fairly close to each other, but about 42% of the time an abnormal situation is caused by human error. I think if you've seen the news recently, they just came out, I think yesterday, saying that the slid off the runway was due to pilot error and the pilot not correcting things properly. So a lot of times these abnormal situations are caused by human error. So it's about 42%. The next highest percentage is equipment failure. Something actually broke that's part of the process that caused something abnormal to happen, or caused the process to stop, or caused some other situation that happened with the process. The other two is just normal operating part of the process. Not every process can be the same and can be perfect each time. So about 22% of the time, something abnormal happens just because it's inherent to the way that the process that may operate. So when we look at situational awareness and we look at all of the things that are available today, especially from a technology standpoint, today's technology capabilities, they allow us to do just about anything we could possibly need to do. When you look at about the release of Archestra graphics many years ago, and all of the things that you could do and the functionality of Archestra graphics and being able to tie those very comprehensive graphics to real-world information allowed the ability to create very realistic 3D type equipment. With the fact that they had the ability to do millions of different shades of colors, things could be in different states with 15 different colors to indicate the different states. Well, that's a problem for me since I'm colorblind, but the other things that were capable in there is the ability to take that real-world information from a controller that came into system platform and linked to the Archestra graphic, or or even other traditional HMIs, be able to do things like animate flames, or animate flow controls, or show motors that are running, and show fans that are actually spinning, show water that's flowing. That list goes on, and I've seen many examples of this. I watched somebody in an application, they spent about 2 days on something that was just the amount of water animation that came through a gate in a dam, and how to make that look the way it actually should. So, some of the questions would be, has all of this technology capability really made operators do things any better? Has it really provided a lot more information that I could see exactly what's going on with that gate on the screen, but if I glanced up to my left, I could see it right out the window anyways? Or is there a better way to utilize today's technology? And I think there is a better way. When we look at the move to situational awareness, there's been, it's almost like a back to the future situation. When we look at, yesterday's applications, one of the things that really kind of revolutionized what was available to do with HMIs is if we had a traditional control panel that was made up with switches and buttons, selector switches and meters and things like that, it looked very similar to this. And we could move this really, in the manufacturing industry. From a manufacturing standpoint, there's this whole move to like paper on glass. Take all the things that were on paper and put them on a screen and make them electronic. Well, we kind of did that years ago in this industrial industry with equipment on glass. So essentially, the example that you really see there is just equipment on glass. And it had a lot of advantages at the time, because certainly if I needed to add a new selector switch or a new push button, it was a lot easier for me to just put it on a screen, put a couple of rungs of logic in a PLC to make it happen, than it was to punch a new hole in the console and acquire the button and wire the button and put the logic in the PLC. So there were some advantages to it. It was just taking the physical world and the equipment world and putting it on glass. Beyond that, it didn't provide a lot more value, other than there could be a lot more information displayed in a smaller area. So when we look at the approach of situational awareness, we see things like this. And we see this design as this flat monochromatic UI style that at first may not look like the best. This is just an example of a demo of a water application. So when you look at this application quickly, and don't worry about the colors, because everything that we do within the Orchestra environment and the situational awareness graphics is all theme-based. So you can determine what the content is going to display with a simple switch, and you can change your entire application. So this one happens to be this kind of green monochrome, but it could be gray, it could be blue, it could be any colors that you want with a simple switch of a button. But when you look at something like this really quickly, the first thing, your attention is drawn to filter 200. The problem with filter 200, because we utilize some of the alarm severity capability that's built in the system platform, and that capability being based on functionality written up in the standards, which I'll talk about the references at the end, and we immediately tell the operator or the user of the screen that, hey, there's a problem with filter 200. And then I immediately moved and look at the level, because that seems to be what's in the alarm. And of course, the red, if you happen to not be colorblind, you can see it's red. If you are, then that red diamond, just the diamond shape with the number 1 in it, tells me that, hey, this is a severity 1 alarm, and it's something I need to deal with. If I was not on this screen, down towards the bottom of the screen in the navigation area, I can provide that same information. So I can see that on the filter 200 navigation button that there's a criticality or severity alarm 1 in that area, and if I click on that, it would bring me directly to that detailed screen, or I happen to be looking at the overview screen so I can see that information as well. So a lot of these concepts aren't really new, right? If we go back and we kind of look at some funny things from the past, and you think back to some old Star Trek episodes, and you see people sitting at consoles, and those consoles were completely made of glass, and they're sliding and swiping their fingers across things. Back then we kind of thought that was science fiction, when, now we all walk around with these smartphones and do the same thing every day. But when you look at this is just a funny example that I went and pulled up, and this is the shuttle bay operations for a Star Trek, one of the one of the space stations. So this is really just a simple detail of just the shuttle bay. And you can see it's kind of broken down into different areas. And over on the right-hand side, I know it's not very easy to read, but over on the right-hand side, you can see the different things that are happening as related to those different areas based on the colors and the graphics that are displayed there, right? So where does this kind of fit into what we look at today? That's kind of a model approach to looking at the equipment. So level 1 being an area-wide overview, right? That's something like if I was the entire space station, then that would be the level 1 area-wide operation. What we may have just been looking at would be maybe a facility-wide overview. So it's just the shuttle bay operation. So, at level 1, I want to look at, I have a goal when I'm going to look at something, and I want to see KPIs. I want to see some summary status. I want to see things that me as a manager or as an upper level person in an organization, in that whole area of the plant, what is it that I need to deal with? What is the situation that I need to go in and react to? And then the level 2 facility-wide is basically key operating screens, any kind of specialty pages around what's going on in that particular area of the plant. And then level 3 is really the detailed operating information, and we can kind of relate this to what we see today with a typical operator screen, with a typical control room application. That's the day-to-day interaction. So it's very similar to what's out there today. People are starting and stopping valves and seeing what the status of equipment is and levels and temperatures and pressures, not really key performance indicators and summary information, but detail about that particular piece of equipment within a facility. And then the level 4, what the level 4 does is it takes in auxiliary information. So it takes other information, and it takes, within this model approach, the context of the model. So things like help screens or trends or alarms and that type of information that's specifically related to the area or the piece of equipment or the detailed operating information that someone is looking at, this is relating that in context of that. So that's something that you'll see, if you get to go to Orlando or you get to come to the show, upcoming shows in Toronto and things like that, we'll show a lot more detail about this. But how all this information can be automatically related in as part of the model and part of the next generation visualization. So when we look at the information or the data that's available, data really doesn't do anything for me without any context. By the way, it's 70 degrees. And that doesn't really matter to anybody because you don't know where I am and you know what the temperature where you are might be. But there's no other information around that. And you don't know the humidity and you don't know whether I was talking about Celsius or Fahrenheit. So without any context around that, it really doesn't mean anything. So and when you do that, you force people or operators to try and remember things, search for things, or even worse, make calculations or interpretations on their own on the fly, which could run into problems. So data without context isn't very good. The pressure is 989.7. What pressure is that? Well, it's just a pressure indicator. I don't know where it is. I don't know what it's supposed to be. I don't know what it is if it's bad. It could be, 990 kPa is a really bad number. Well, I don't know that by looking at this, but I'm very close to that. So how far is it from my set point? Is it close to being alarmed? Is it inside my normal operating range? These are really, really important things that I need to know to be able to make decisions. So at best, this is an inconvenience because I have to do this interpretation of that data myself and turn it into information within my mind or within my brain. But during, problems, it just relates to a slower response time, which causes more problems. So things start to cascade as there are problems with the system. So being very aware of the situation is always going to allow me to react faster to any kind of upset in the process. So turning data into information, this is a very simple example here of a meter used to represent a transmitter and a controller that's controlling the flow for this meter. So there's some control system controlling the flow. Everything that I'm talking about in this presentation in the situational awareness, that's all built in. It's all built into our graphics library. So nothing that I'm talking about you have to create. It's all already there, and you can simply use it in your application. So if I take a look at this example, there are some more details than I had in that previous example where we simply knew a value. So here, well, let's move on to this. And all of the meters within our library show certain reference values, and you can determine what detail of these values you want to display. As a matter of fact, with next-gen functionality, you have the ability to display things based on the level of the visibility level of it. So if I zoom into something, I can display a lot more information. If I'm zoomed out and there's a lot of things on a screen, I display even less information. So all of this stuff is built into these graphics. So all of these things help you interpret the value. This meter, there's my high alarm, my high alarm. There's my high alarm. There's my tracker. This is my set point has recently moved. Here's my set point. There's the actual value. We can see at 123.4. There's my low alarm. There's my low alarm. And at the bottom, the C indicates to me that it's a loop and it's in cascade mode as opposed to auto or manual mode. So I've taken all of that data and I've really turned it more into information. So I can see that gray box is my normal operating range, and then there's my value, and it's outside my normal range. So there's a lot of data that's put together in this display and really displayed to me as more information. And that's because of the mind's ability to interpret the graphics faster than it can interpret numbers and do any kind of calculations on the numbers. So this pre-attentive processing is really the important thing. So, just some examples of the things that we do within the library. You can use the color hue. So, it's very easy here to look at the first one, and I can see exactly where the difference is because it's red. And the next one using the color intensity. The next one putting in a different shape. So, being colorblind, it's a lot easier for me to recognize that star. Just like my example with the alarm indicator before, it was a lot easier for me to recognize that rectangle than it is the color red, especially if a lot of the colors are the same. And then there's a line length. And there's an enclosure, so it's easier for me to see that alarm because a box showed up around the area with the red diamond with a number 1 indicating the severity of the alarm. So orientation and line width and position of lines or graphics or objects, different sizes of graphics or objects, all these things make it very easy for me to see information instead of just seeing different data values on a screen and having to then process that. So, the example of the alarm, here's an example of a situational awareness graphic for a storage tank and some filters. And if there's a problem here, I may see an alarm appear, and it easily draws my attention to that particular area of my application. And I can immediately tell that, based on the way my standards are put together, that this is a severity 2 alarm. So if I get to this and take care of this in the next half hour, I'm probably going to be okay, or whatever those standards that I happen to use are. So I can react to that as needed. So some of the meter components, again, these are all part of the library, so you don't have to do anything to build these. You simply tie them to the attributes that are coming from the control system, and they just function. So here's a same example of that flow control meter, cubic meters per hour there, and it's in cascade mode. I'm just going to do a little quick test here. I'm not sure how it's going to show up on the GoToMeeting, but if I do a quick test, something just appeared on the screen. And if you happen to see it appear on the screen, you probably did a very quick interpretation in your mind as to where that value was without even seeing a number. So I'm going to go ahead and do that. So I go ahead and do that again, and the same thing just happened. You saw something very quickly, and you were hopefully able to interpret it in your mind without having to do anything else. So one more time, let's go and put one more on the screen. So there was 3 things that popped up there, and when you look at them, they were only there for a half a second each time. So the first one that popped up had that dot showing me where my PV is inside its normal operating range. As a matter of fact, it was right in the center, and it was very easy to see for me, since I've seen it a few times. I'm not sure how everybody else made out on it, but it was very easy to see that it was right within that operating range. The next time it popped up, it was at the bottom of its operating range, and the last time it popped up, it was outside of its operating range. So it was very easy for me to see that. Now, that may not indicate it's already an alarm. It may indicate to me that, hey, I better go look at that before it does go into alarm and cause me a problem. which is going to be a lot different than me just seeing a 137.4 on the screen when it's supposed to be 135 or 132, whatever the numbers might be. I have to think about that. This is giving me a very quick indication as to where it should be. So another example with some line lengths. Screen real estate is always important because you want to display a lot of different things on a screen and give people access to that, and of course allow them to interpret it and make decisions based on that. So if you look at this, I left it up there for a long time. What's the largest value? I happen to know. What's the smallest value? I happen to already know because I've seen it numerous times. But if I display this with a line length, it's much easier for me to see. And these aren't in the same order because you can see that B2 is actually the highest value at 99. B10 is, even though it is at the bottom, is the lowest value. So it really wouldn't matter the order of these values. But this graphic easily allows me to look at that and see what the largest and smallest value is within the set of things that I'm looking at. So I don't have to put a whole lot of thought into this. As far as screen real estate, it takes slightly over double the screen real estate to do this, but of course this is something that I could have as a drill-in if I needed to make it easy for an operator to see that. So how line length fits in. So again, all of these things are part of the situational awareness library, so everything that you're seeing is in there and usable today and has been almost for a couple of years now. So from a trend standpoint, trends are very effective for attaining the level 3 type situational awareness projection as to, okay, I'm looking at something and I can see where it's been and I can kind of see which way it's going. So a trend is very useful for that. So there's a lot of trending capability that's been built in to the situational awareness. So you can see things like the startup curve. So if I'm looking at a trend and when I start my furnace and I start, heating it up and getting the furnace online, I want to see my operating values stay within a certain range. So I have a startup curve, very easy for me to see it's within that range. A trend tail, so the center one, when you look at it, if you look all the way to the right, that's really the same exact meter that I've been talking about in the previous slides, and it now has a trend attached to it, so I can see where that value has been over time. And I've seen this utilized where there's a lot of different meters on the screen, and as you hover the mouse over, the trend tail shows up. So you can see historically over the last 15 minutes or 2 hours, where that value has been without taking up all of the real estate that you see there. So that trend tail could come up over any other graphics that happen to be over on the left-hand side and just show me the trend tail as it is attached to that meter. Another powerful one is the spark line. So when you look at the spark lines, they're very small effective trends for communicating any kind of volatility that's happened over a period of time. Because I'm just looking at, say, the last 15 minutes, and I'm looking at the min and maxes that happened in the last 15 minutes, and I see a very simple graphic that shows me that. So I can see very easily go back and see, wow, what has been the maximum value or the minimum value that it's changed over time, when I can see, within the last whatever time period it is, that's my normal operating range, and then it drastically changes automatically and shows me any of the outliers, so I can see that, there was a problem at a particular time. So that's just an example of some of the trends. Deviation from target, I kind of talked about this with the meter, making it very easy to see with that meter that we have, but we have other ways of showing it, so some different KPI bars where I can see, my level, my flow, and my pressure, and where they are and how far they're deviating from their target, whether they're above or below the target, and what's that percentage that they're away from the target. Deviation chart, again, with a bunch of different values, and a target chart there, kind of, how that pie chart that seems to expand based on those values and where they should be, and then the variable monitoring bars that are there as well. These are all just examples of displaying different values here, and I'll get into some detail on these examples as well. The next one is kind of one of my favorites, is the Polar Star chart, and the Polar Star allows me to see where things are deviating from target. And the important thing about all of these graphics is they don't require you to reconfigure them at all. They're smart enough to adapt to the values or the attributes that you add to them. So you see over on the left-hand side, you can see some different 4-spoke diamonds and squares and 6-spoke and 8-spoke Polar Stars. Over on the right, you can see that system summary. in a diamond-shaped polar star, or sorry, a square polar star, and then you see some values: crude, gas, water, and oil. So those are four completely separate variables, process variables, completely different set points with completely different engineering units and engineering scales. Yet they'll, put into a polar star, they'll automatically scale to whatever their operating range and whatever their values are based on the engineering units and the attribute that you assign to it. So a lot of different ways of showing these deviations from target that make things a lot easier for an operator to see. There's a very extensive library of these symbols, and the library will continue to be enhanced when we come out with the next version of System Platform. There are actually a lot more situational awareness graphics that have been added to the library, so that'll extend the capabilities and what's available. But just to kind of quickly go through some of the things, you can see from all of the folders that are listed there, all of the symbols that are available, but you can see there are some alarm symbols. So there's an alarm history page, an alarm banner, a runtime page, an alarm light, severity light. Those are all the things that you see utilized within those graphics. So the little red diamond that shows up on the buttons for the alarm severity, that's one of those already pre-built graphics. The history page, or I'm sorry, the alarm banner that showed up on one of the graphics that you saw earlier is there. You can see some of the unitizers, so some of to display equipment ID or to display a meter marker. You know, those things are already there, so you can be building everything with these pre-built symbols. You don't have to create any of these symbols yourselves. Some electrical symbols, so an electrical reactor, transformer, those different symbols there. Some of the input things, you always need to input a value entry, so there might be a human value, a numerical value entry that somebody needs to click on and enter a value, and it'll have all of the things built in to display it correctly and deal with the engineering units and min and max range and all those things. Page navigation buttons have already been built into this, so you can use those to navigate throughout your model. Text entry, if I'm just entering in text, again, having, you know, taking into account what attributes have been added to it. And then the different meters, we kind of went through some of the meters there. So, you know, the connector meter, the KPR bar, the multi-level meter, which I think is the one that I was showing the detail on. So a lot of things available in this library. Those are just some of the examples. Again, you can see the whole list of, you know, alarms and dashboard tools and electrical and equipment and input and meters and some of the other miscellaneous stuff and polar stars. Just to drill in a little bit, if we look at the dashboard tools, some of the things that you see, this is actually showing a preview of the graphic in the development environment with box charts and bar charts, deviation charts, gain and loss charts. All of these different things are already pre-built, and because of the wizard selections, the way they've been built as symbol wizards, you can drop them down and tell them how many points or how many bars that they need, and all of that configuration is simply done within the wizard environment, and I'll show you some detail about that in another example in a little bit. So there's an example of the dashboard tools. Here's the polar stars that I mentioned. So, you know, the different polar stars that are available here, the 5 different ones that I can just go ahead and select those from the polar stars and put those into an existing application. Equipment tool set, so valves. So there's a very ample selection of these discrete valves, and everything that I'm showing you here is currently released software, and as I mentioned, the next release will have even a lot more permutations of these different graphics and things that are available. So there's you know, the two-way valves, and these are just examples of those valves being dropped on the screen. So I can see a solenoid, a digital, a rotary, a diaphragm, spring, manual, the different body types on the valves. So my two-way valves. So here's all the different, you know, two-way valves and how the two-way valves can be oriented. The different three-way valves that are available, same thing, and how they can be oriented. And the same thing with the four-way valves and how they can be. So literally, this is equivalent to, you know, hundreds is probably too low of a number. Hundreds, even 1,000 different permutations of these graphics that can be dropped on the screen and simply tied to your existing attributes without you having to do any other extended engineering to make them work and make them operate. Trending, I mentioned, again, is another thing that's available as part of the library, and I kind of showed that in when I talked about the different trends earlier. So you can see there that there's the Situational Awareness Trend multi-pen, Situational Awareness Trend single pen. The interesting thing about these pens, these trend pens, is they were designed with performance in mind. And what I mean by that is if you look at one of the most powerful things that's available in an HMI SCADA application is the ability to it's also one of the, let's call it most expensive, and that's not from a licensing cost, that's really from a resource cost and a configuration cost, the most expensive to deal with. Meaning that if I want to put a trend, I want to trend 5 different values, in most cases I have to have some separate object that trends those values for me and retrieves those values from some long-term storage location, unless it's just a very simple short-term real-time trend. And from a complexity standpoint and a processing standpoint, that can be rather expensive. So I can't go to a large overview screen and drop 100 different .NET controls or ActiveX controls and have them automatically configured based on what somebody's selected and have that operate efficiently. So what we wanted to do when we designed the pens that are part of the situational awareness is we wanted to make them as resource light as possible, and we've tested hundreds of these things for 1 hour, 2 hour time periods on a single screen with the goal of making an extremely fast call-up time. And the other thing that I had mentioned, I helped a customer who had a fairly complex screen. He had about 68, I think it was maybe 70, something like that, different values that were displayed in existing 3D looking meters, and then when they clicked on that, drilled into a lot of detail as to what was going on in the meter. We wanted to redesign that so we could very easily, without clicking and drilling and having to back out of things, get into the different values. So we kind of did it with a visibility capability. So even though everything was all lined up, as we hovered over one of those values, it would add more information to it, as well as it would add an hour of the last trend of that value. And then as soon as it was moved off, the trend went away and the screen went back to normal. So it was a very large control room operating screen that displayed a lot more information when something was hovered over. And we took advantage of all the situational awareness stuff in order to be able to do that. So just an example there on the trends. So if we look at the entire library, I talked about these 3 major categories already, but there's just kind of a quick listing of the equipment with the agitators and the feeders and the heat exchangers and fans and miscellaneous equipment and pumps, rotating equipment, tanks and vessels, so forth and so on. The meters and polar stars kind of fall into the same type of category with a set point and a deviation from set point type control environment. And then the dashboard tools with the bar charts and the column charts, pie charts, target graphs, comparison charts, all those different dashboarding tools. They all kind of fit into those different levels that I talked about of graphics within the situational awareness definition. So I'm probably not going to use a dashboarding tool on a level 3 graphic, because a level 3 graphic is probably going to consist of equipment. And it may consist of some of the center things like meters and polar stars, but that's really to provide situational information to an operator who may be using a level 3 graphic, and it's not going to have bar charts and column charts that have summary information and key performance indicators for an entire area or an entire line or whatever that might be. So when we look at this, there's 100+ wizards or so in there, and even more, like I said, with the next release. And the way the wizards are built with all the different combinations, there's somewhere over, and maybe not in this release, it might be slightly under, but the next release, somewhere over 1 million different unique combinations of these symbols. And the important thing to remember is these symbols are not designed for somebody to just take and put in their application and take apart and redo. They're designed for you to use them directly in your application, and they have everything built in for you to simply tie those to values that you already have in your application and have them immediately functional. So one of the things that I didn't talk about in all of the graphics, I just briefly showed it in the list of all the different symbols that are available, is the alarm symbols. So the alarm symbols, one of the changes that we made within System Platform to the alarming a few versions ago was adding this severity in. So under the hood, we added the capability to have severities. And this is important from a situational awareness standpoint. And one of the things that actually came out of this is a product that we have called Alarm Advisor, which we'll save for another webinar some other time. But one of the things that we realize is, and people are realizing themselves, there are too many alarms in their applications for anybody to really be able to effectively react to those alarms or situations in those alarms, and some of them don't even need reaction. They're really just kind of nuisance alarms. And I love to see this when I was at a customer's cogeneration plant, and we were sitting in the control room reviewing some stuff, and every 3 or 4 minutes some alarm blared, and somebody reached over and pressed a button on the screen, and I had no idea what it was. They just acknowledged it. And probably shouldn't have been blaring an alarm every 4 minutes if it wasn't that important. But it made me nervous every time it happened. But so taking that into account, one of the things we did with InTouch is we had this 999 levels of alarms. So with all these different levels of alarms, people tended, since they really didn't cost anything, nobody had to put a light on a board, so it lit up when there was an alarm. They didn't have to drill a hole and get the light to put on the board. They could just kind of check a box and say, yeah, this is an alarm, and here are its limits, and in they would come. It made alarms very inexpensive and easy to add, so somebody could easily put them in an application without a whole lot of thought. And when we've started looking at that and said, wow, that's way too many levels, and people don't really use it, a lot of people say, well, when I have 1 to 300, it's really this priority type alarm. So we kind of boil that down into these severities, and based on some of the standards, which I'll reference at the end, that we built a lot of this stuff on, a severity 1 alarm is something that requires a response in, typically less than 5 minutes. This is a pretty serious situation, and somebody needs to go do something about it. So the icons that you see on the left-hand side with the indicators, that's something that we adopted from a standard, but you don't have to use it. Those are globally settable at the entire System Platform application level. So you don't have to go change any graphics. You simply say, I want to use this as my indicator, and I want this to be my color, and you can go set that. So the next one down, the severity 2, typically something that I got to deal with it in the next half hour or so. And severity 3, probably under an hour. And severity 4, I could probably go to lunch if this just came in and come deal with it after I went to lunch. So over on the right-hand side, you see an example of that. And again, that alarm border is built into every situational awareness graphics that we have. So all you have to do is enable it, and it will be turned on. So if you have alarms, it will be there, and you will get the indicator, you'll get the severity, and the alarm border will light up around it. And you'll see some other examples about that in a minute as well. So I just wanted to kind of go into some other examples. I have some demo example and then a real-world customer example. So I have, actually it's in the wrong order. It should probably say water equipment and injection mold equipment here. But this example of a water application, this is kind of similar to the first screen that I showed where I had all the push buttons and lights and selector switches and meters. This is an example of a water application. And it's a graphically pleasing water application or graphically pleasing HMI application, but it's not very good on information. It's not very easy for me to see information because there's a lot of different uses of colors, a lot of different gradients, and a lot of different shading and things like that. And then there's green on the valves and red on the valves and a lot of these things that really make it kind of difficult to see what's going on. Here's that same application that's redone in situational awareness. I apologize for one of the graphics because I think before I took this screenshot, I was drilling into the Polar Star to show somebody how it was actually built, which I would hope that nobody would ever need to do because it simply works when you just drop it on the screen. But here you can see that whole graphic redone as a situational awareness graphic. So I can see my key performance indicators for the influent flow and the valve and the filter level. I can see that my effluent turbidity is rising there. It's very easy for me to see that spark line tells me, hey, that value's been going up pretty quick over whatever period of time. And then I can see that meter that has the turbidity over there on the right-hand side that shows me, yes, it's within its operating range. And then there's that polar star. And again, the interesting thing about the polar star is the fact that it has the flow, the turbidity, and the level all part of the same graphic. And it doesn't matter that their engineering units are off. I simply add the attribute to that polar star, and it's simply going to work within the operating range of the attributes that I've added to it. So that's just an example of something moving from a standard application, standard graphical 3D type graphical application to a situational awareness type application. And again, it doesn't have to be this drastic, and I'll show you an example of that in a minute as well. So if we move on to the next one with, this happens to be an injection molding application. And if you tell me really quickly which zone is the one that has the highest deviation. So maybe there's no alarm here, there's no problem, but I want to know which thing is the farthest out of deviations. Probably everybody's looking at those numbers and thinking about it and trying to see the difference between them. But if I was to show you this and say, quick, what's the highest deviation? Pretty simple that you're going to tell me zone 5 in a half a second. But if you go back and look at this one, you can see that zone 5 has a Sept 81 and its PV is 372. You probably had to start on the left-hand side and do the actual calculations in your mind to determine where they were and how far off from set point, where this one immediately tells you that that is the zone that's out of spec, and maybe I'd have to deal with that. Again, there might not be an alarm. If there was an alarm, I might have a border over that spoke, you know, a red border telling me that there's an alarm or a problem with that. But it easily tells me that there's a deviation between the set point and the PV for that particular value. The other thing that's important here is, again, I don't have to do everything. I don't have to go the drastic change of the water application that we just saw earlier. This is something that I did for an OEM customer where they said there's no way they could get their customers that buy their equipment to switch from what they've been using with pictures of the machines on it for many years to something that doesn't have those pictures anymore and had the situational awareness functionality. So there was a kind of a, let's look at it and let's put situational awareness graphics in it that are very, they don't take over the application, but see what the feedback is and see what the operators like better. I tell you what, if I was an operator, and I used to actually do some control work for extrusion machines, and these were some of the things that I really wish I would have had the capability to do when I was doing it years ago. Now, this capability has been there forever. We've just made it extremely easy now, and we've built it all for you, where you just have to drop it into your application. So again, really quick, I can see what's going on. So, the best of both worlds, if you look at this example, this is that injection molding machine, and I can look here and I can see what my temperature zones are, and my previous example had the set point right next to it, so I could see what the set point was. The current version of the application, I actually just have to hover over the number or click on the number to see the set point, but I can very easily see the deviation over on the side. So if I was just to walk up to this piece of equipment and press a start button and the temperature zone started heating up, it may look something like the polar star that's over there on the right. So I can tell how kind of far I am from this thing actually being ready for me to run. It's going to look more like something like this, something like this when it's ready to run. So my temperatures are all within, the tolerance that I've defined within that situational awareness graphic. So, is it wrong to do it the other way? No. Is there another way to do it? Yes. Is there a better way? Yes. There's also combinations. Doing both doesn't have to be any kind of a drastic change. From a configuration standpoint, this is what the polar star looks like. So if you've been in the development environment and you've done anything with Orchestra graphics, I simply went into my injection molding machine template and I dropped in the 8-point polar star because this happens to be an 8-zone injection molding machine. And when I dropped it in and I double-click on it, I have these wizard options. And the wizard options allow me to go in and say, yeah, I want it to be normalized, I want it to have a label, I want a custom property-based label, and then I want to have all the alarm borders, so I want to turn on the status indicator for everything, so if one of the values is bad, it'll show up with the wrench or, whatever the status is. I don't have to do anything other than turn on these wizard options in order to be able to do this. So I want to have all of the alarm board. I want to have alarm borders on all the different spokes. And then I simply go in and say, once I've turned those on, it says, well, here's all the values that you need to tie to it. So I simply tie my temperature zone PV to the different spokes. So my alarms, my PV, I give it a label, and then I tell it the tolerance, because I don't really want that thing to have the whole tolerance of my temperature that swings from 70 degrees to 500. I just really want it to show within tolerance whether it gets in 5% or 10% or 15% of the set point. So I can set that value for all the different zones as well. It all normalizes everything itself. So it doesn't matter to me if one zone has a temperature set point of 500 and another zone has a temperature set point of 300. It's still going to graphically indicate it just like the graphic in runtime without, it's going to take into account the difference in those engineering units. Nothing I have to worry about. It takes care of it automatically for me. All right, so let's take a look at a real-world example. Richards Bay Minerals, Rio Tinto application. They looked at situational awareness. They're moving their operations around. They needed a better way to be able to interact with things. So Richards Bay is a subsidiary of Rio Tinto, happens to be in South Africa. Their vision is to be the safest, most reliable, sustainable industrial mineral supplier, right? There's some of the products that they have listed there. So they had an application, and their application didn't look much different than the water application that we looked at. So this is a traditional, let's call it a level 3 operator interface, or HMI, or SCADA display. So this operational screens in most applications, they evolve over time, right? There are more things, there's equipment added, there's more equipment integrated, there's more graphics added to the screen. So the first version of this 18 years ago may not have had all of the same stuff. Maybe it didn't have the left rear displacement and the freeboard configuration in there. The screens kept getting busier. The operator had more things to do. So there's more and more things that the operator needs to do today. Level 1 graphic example. So this is what their level 1 graphic is, or was. It's a very busy display. Level 1 is functionality that somebody as a manager or a supervisor is supposed to take a quick look at and find out what, based on those key performance indicators, what is it that I need to do to drill, to go in and address. This is what the level 1 graphics move to. Very easily, moves me into where I need to deal with in the concentrator, and the yield for the concentrator is a problem. Displayed on that other screen, I believe. Good luck finding it, right? So a level 2 graphic example, same thing. Level 2 pulled out of this graphic that they just called their overview graphic with now an entire area of the facility. So the level 3 graphic is more of the operator's graphic. So this is the first one that I showed, and over on the right-hand side, that's what they've evolved to display just about everything that they display for the level 3 graphic that you see on the left-hand side. Much easier for the operator, much easier for anybody who doesn't even know anything about the process to go and look at it and see where the process is. So these are just some other examples of how they evolved that graphic. They had to break it down into a few different graphics to display the same information, but those graphics were targeted at different audiences, so it was fine that they were different graphics instead of having a single graphic that everybody looked at. So remember when I brought this one up. There were some graphical changes, right? It turned from that into this. So there's the old one, there's the new one. There's a couple of things over on the right and the left-hand side that I just want to drill into a detailed example of. So if we look at this, this was this left rear displacement. And this is the way graphics were built at the time. We had this 3D capability. So this particular graphic was turned into this one using a polar star. So the polar star is indicating all of the same information that the graphic on the left is. So the left graphic, the old one, it's graphically appealing. It has a 3D look to it with buttons and bar charts and things like that. It really doesn't take up too much space. It works really well because all the units happen to be percentages. So they're all in percentages, as opposed to if one of those units was in Fahrenheit, another one is in PSI, and another one is, in some other level, liters or gallons or inches, whatever it happens to be. So the graphic on the right uses the shapes and the patterns. Takes a little bit less real estate because it's actually shrunk down a little bit more in the application. I tried to scale it up bigger here. And it works with any units, so it doesn't matter if it's all percentages or if it's like we saw in the water application, a turbidity, a level, and a pressure with completely different engineering units. It displays a lot more visual indication of what's going on with the process than the one on the left, and really, in the long run, the whole thing works a lot better. So some of the things that they shared back with us, some of the lessons that they learned, is to get input from all the stakeholders. It was really important in that project to do that. So the operators need to be involved in this process. The other one that I mentioned with the OEM, where they went back and they said, no way, the customers aren't going to do it, so they're not going to take this whole thing being done. So they kind of went back to their end customers and said, well, how about if we just do this stuff and you try it out and see how it works? So these are kind of the important things. The technical solution is really a simple part of it. It's really getting the people involved and the people to adopt it. And in most cases, if you're going to make somebody's job easier, they're probably going to be willing to move in that direction. So kind of some of the bottom lines here is seeing things faster and easier in any industry and any application really is going to translate to money, whether that's money saved from not having to deal with problems or not having to scrap product, or whether that's money earned based on being able to produce more product or produce better quality product. It's really going to translate into more money, whatever your currency happens to be. And probably more importantly, it's also going to translate into better safety. Because if I can address a boiler issue before the boiler blows up, long before the boiler blows up, it's certainly a much safer process for me to be able to do that earlier, better than later. So, again, when we look at the benefits here, these are kind of straight out of a handbook in some of the studies. With a traditional HMI, if I'm looking at a traditional HMI screen, detecting an abnormal situation before an alarm occurs, that's kind of going back to that early example where I had the set point just outside of the operational area, but it really wasn't an alarm. Being able to detect that earlier by utilizing something like that operational area and the set point just outside of it, it's about a 5-time increase in the amount of time that I can find that issue before it becomes an alarm or before it becomes another issue where I can deal with it. So the success rate in handling those situations, about 70% with a traditional HMI, about 96% with a high performance or situational awareness type HMI. So 37% increase over that. Time to complete abnormal situation analysis or tasks or fix them, 18 minutes with traditional HMI versus 10 minutes with high performance or situational awareness HMI. So about 41% reduction in the amount of time that it takes to complete those processes. So like I said, we didn't make all of this stuff up. As a matter of fact, we got involved and purchased some standards that we used before we developed the library. So we had a lot of consulting and a lot of industry standards that went into this. So here are some references with the High Performance HMI Handbook, the ASM Consortium Guidelines, Designing for Situational Awareness, Information Dashboard Design, and Show Me the Numbers, some references for all of the things that I had in this, that I talked about in this presentation, as well as how we designed and developed all of the symbols that are part of our situational awareness library. So that's pretty much what I wanted to cover. I'm about 4 minutes over because I thought I was going to go about 50 minutes. So I wanted to let everybody go for lunch, and I wanted to thank everybody for their time. My email address was up there. Edward may chime in here to finish things up, but my email was in there. It was brian.martin@wonderware.com. If you have any follow-up, certainly with Wonderware Canada East with Edward or Jason or Mark or Bruno. From a sales standpoint, if you have anything, you can contact any of those guys. And Edward?
Yep. Thanks for joining the presentation today. If you guys have any questions, feel free to email support@wonderwarecaneast.ca or brianmartin@schneiderelectric.com. Thank you, and have a good day.
Thank you.